For both applications, you will need a specific type of wire. This wire is THHN/THWN-2. It needs to be gauge #12 American wire gauge. The temperature rating should be 125 degrees centigrade. It must have a wet location rating of yes. When you go to the supply house, ask for 125 degrees centigrade THHN/THWN-2 #12 wire for wet locations. THHN/THWN-2 wire is rated for 90 degrees centigrade in dry locations and 125 degrees centigrade in wet locations. This is due to the moisture resistance of the insulation. As such, this wire can be used in both applications. 125 degrees centigrade rated wire is not new. It has been available for several years and is becoming more common as light-emitting diode and high-intensity discharge lighting fixtures increase in popularity. These fixtures require high temperature rated wire due to the heat generated by their lamps. Also, make sure that the circuit breaker or fuse protecting the circuit is rated for the ampacity of the #12 wire. Always follow all local electrical codes and the manufacturer's instructions when installing the wire. Use appropriate sealing fittings at the points where the wire enters or exits enclosures or fixtures. And finally, protect the wire from physical damage during installation and use. Electrical conductors come in various sizes, each designated by an American wire gauge, or log, number. The AWG system is used to standardize wire sizes and ensure consistency electrical installations. The smaller the AWG number, the larger the wire diameter and the higher its current carrying capacity. Common wire sizes include #14, #12, #10, #8, and #6, each suitable for different applications based on their ampacity or current carrying capacity. The ampacity of a wire depends on several factors, including its size, insulation type, and the ambient temperature in which it is installed. The National Electrical Code, or NEC, provides tables that specify the ampacity of different wire sizes and types under various conditions. For example, #12 American wire gauge copper wire with THHN insulation has an ampacity of 20 amps at an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. However, this ampacity must be adjusted if the ambient temperature is higher or if the wire is installed in a conduit with other current carrying conductors. When selecting a wire size for a specific application, it is essential to consider the load it will carry, the distance it will run, and the voltage drop that can be tolerated. Voltage drop is the decrease in voltage along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it is often necessary to use a larger wire size than would be required based solely on the load. Wire insulation is another critical factor to consider when selecting electrical conductors. Different types of insulation are designed for different applications and environmental conditions. Common insulation types include THHN, THWN, THWN-2, XHHW, and OFF. THHN insulation is a popular choice for general-purpose wiring in dry locations. THWN insulation is suitable for wet locations, while THWN-2 insulation can be used in both wet and dry locations and has a higher temperature rating than THWN. XHHW insulation is another type of insulation suitable for wet locations and has a high heat resistance. UF insulation is designed for underground feeder and branch circuit wiring and is resistant to moisture and sunlight. The temperature rating of wire insulation is also an important consideration. The temperature rating indicates the maximum temperature at which the wire can operate safely. Common temperature ratings include 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. It is essential to select a wire with a temperature rating that is appropriate for the application and the ambient temperature in which it will be installed. Using a wire with too low of a temperature rating can lead to insulation failure and potentially cause a fire. In addition to wire size and insulation type, it is also important to consider the conductor material. Copper and aluminum are the two most common conductor materials. Copper has a higher conductivity than aluminum, meaning it can carry more current for a given size. However, aluminum is less expensive and lighter than copper. Aluminum wire is often used for large-gauge conductors in service entrances and feeders. When using aluminum wire, it is essential to use connectors and terminals that are specifically designed for aluminum to prevent corrosion and ensure reliable connection. Electrical connections are a critical part of any electrical installation. Poorly made connections can cause overheating, voltage drop, and even fire. It is essential to use proper techniques and tools when making electrical connections. Common types of electrical connections include wire nuts, crimp connectors, and terminal blocks. Wire nuts are used to connect two or more wires together. Crimp connectors are used to terminate wires to terminals or equipment. Terminal blocks provide a convenient way to connect multiple wires together. When making electrical connections, it is essential to ensure that the wires are properly stripped, twisted, and secured. Wire strippers should be used to remove the insulation from the wires without damaging the conductors. The wires should be twisted together tightly and then secured with a wire nut or crimp connector. Terminal blocks should be tightened to the manufacturer's specified torque to ensure a secure connection. Grounding is an essential safety measure in electrical installations. Grounding provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. All electrical equipment and appliances should be properly grounded. Grounding is typically achieved by connecting the metal enclosures of equipment and appliances to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode should be connected to the neutral conductor at the service entrance. Ground fault circuit interrupters, or GFCIs, are another important safety device in electrical installations. GFCIs are designed to protect people from electrical shock by monitoring the current flowing through a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the power and preventing electrical shock. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. Surge protection is another important consideration in electrical installations. Surges are transient overvoltage events that can damage electrical equipment and appliances. Surges can be caused by lightning, utility switching, or other electrical disturbances. Surge protective devices, or SPDs, are designed to protect equipment from surges by diverting the excess voltage to ground. SPD are available in various types, including whole-house surge protectors and point-of-view surge protectors. Electrical codes and standards are essential for ensuring the safety and reliability of electrical installations. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC provides detailed requirements for electrical installations covering topics such as wiring methods, grounding, overcurrent protection, and equipment installation. Local jurisdictions may also have their own electrical codes that supplement or amend the NEC. It is essential to follow all applicable electrical codes and standards when installing or maintaining electrical systems. Electrical safety is paramount in any electrical installation or maintenance activity. Always de-energize circuits before working on them. Use appropriate personal protective equipment such as insulated gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental re-energization of circuits. Be aware of potential hazards, such as exposed conductors, damaged insulation, and wet locations. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical testing and troubleshooting are essential for maintaining the safety and reliability of electrical systems. Common electrical tests include voltage testing, continuity testing, and insulation resistance testing. Voltage testing is used to verify that a circuit is de-energized before working on it. Continuity testing is used to check for broken wires or open circuits. Insulation resistance testing is used to assess the condition of wire insulation. Troubleshooting electrical problems requires a systematic approach. Start by identifying the symptoms of the problem. Then, use a multimeter or other test equipment to check for voltage, continuity, and resistance. Consult wiring diagrams and technical documentation to understand the circuit. If you are unable to resolve the problem, hire a qualified electrician. In this specific case of using #12 wire rated 125 degrees Celsius as supply conductors for in-ground HADCO 175 watt metal halide uplights for lighting a flagpole and for feeding metal halide wall floods by Hubel, several considerations apply. Firstly, the choice of THHN/THWN-2 wire is appropriate due to its 125 degrees Celsius rating in wet locations, which is necessary for the in-ground uplight application and suitable for the wall floods as well. Secondly, ensure the #12 wire is adequately protected by a circuit breaker or fuse that matches its ampacity, typically 20 amps for #12 American wire gauge copper wire, but always verify based on the specific installation conditions and local codes. Thirdly, when installing the in-ground uplights, proper sealing fittings are crucial to prevent moisture from entering the fixtures and wire connections, as this can lead to corrosion and electrical faults. Fourthly, for the wall floods, ensure the fixtures are rated for the voltage and wattage of the metal halide lamps being used, and that the wiring connections are made securely and protected from environmental factors. Fifthly, follow all manufacturers' instructions for both the uplights and wall floods, including proper installation techniques, grounding requirements, and maintenance procedures. Sixthly, inspect the wiring and fixtures regularly for any signs of damage, corrosion, or wear, and address any issues promptly to prevent safety hazards or equipment failures. Seventhly, consider the ambient temperature conditions in the area where the lights are installed, as extreme temperatures can affect the performance and lifespan of the wiring and fixtures. Eighthly, ensure that the wiring is protected from physical damage, such as from lawn equipment, vehicles, or vandalism, by using appropriate conduit or other protective measures. Ninthly, verify that the installation complies with all applicable local electrical codes and regulations, including requirements for wiring methods, grounding, and overcurrent protection. Tenthly, document the installation, including wiring diagrams, fixture specifications, and inspection records for future reference and maintenance purposes. Remember that electrical work can be dangerous, so if you are not qualified to perform the installation or maintenance task safely, hire a licensed electrician to do the job. The use of metal halide lamps in lighting fixtures presents specific considerations due to their operating characteristics and safety requirements. Firstly, metal halide lamps require a ballast to regulate the current and voltage supplied to the lamp, and the ballast must be matched to the lamp's wattage and voltage specifications. Secondly, metal halide lamps generate a significant amount of heat, so the fixtures must be designed to dissipate this heat effectively to prevent overheating and premature lamp failure. Thirdly, metal halide lamps emit ultraviolet radiation, so the fixtures must have a lens or diffuser that blocks or reduces this radiation to protect people from potential harm. Fourthly, metal halide lamps contain mercury, so they must be disposed of properly to prevent environmental contamination. Fifthly, metal halide lamps may exhibit a phenomenon called end-of-life cycling, where the lamp turns on and off repeatedly, indicating that it is nearing the end of its lifespan and should be replaced. Sixthly, metal halide lamps may experience a delay when starting up, especially after being switched off, so it is important to allow sufficient time for the lamp to reach full brightness. Seventhly, metal halide lamps may change color over time, so it is important to replace lamps and match sets to maintain consistent lighting quality. Eighthly, metal halide lamps are sensitive to voltage fluctuations, so it is important to ensure that the voltage supplied to the lamp is within the specified range. Ninthly, metal halide lamps may generate radio frequency interference, so it is important to use shielded wiring and filters to minimize this interference. Tenthly, metal halide lamps may be affected by ambient temperature, so it is important to consider the operating temperature range of the lamp when selecting fixtures and locations.